For this example, we're looking to see what are the corresponding parts that are congruent in the triangle. If we notice, all of the parts have corresponding parts that are congruent, so the two triangles will be congruent as well. When we write our congruent statement, we have to be very careful how we write it. It has to be written in the same order for both. So if I take triangle JKL, I'm going from 3 marks on an angle to 1 mark on an angle to 2 marks on an angle. And I have to do the same thing for the second triangle. So I look for the one with 3 marks, which is T. So I start with T because J and T correspond. Then I go up to S because K and S correspond. And then I go over to R because L and R correspond. So that's one way to write this. We could write this a number of different ways depending on the order in which we do the first one. That determines the order of the second one. Similarly, we can look at all the angles and we can say that angle J is congruent to angle T, angle K is congruent to angle S, and angle L is congruent to angle R. And then finally for the sides, again we look at the markings once again. So if I look at JK is going to be congruent to the other one with one marking, which is ST. We can look at KL and say that that is congruent to the other one with 2 markings, which is SR. And finally, we can look at JL, and since JL has 3 markings, the other one that has 3 markings is RT. So those are our congruent parts. And again, they'll have something similar to what I have. JKL, TSR, which was exactly the same. Then JT, KS, LR, JK and TS, KL and SR, LJ and RT. Now for this one, we know that these two figures are congruent, and again, a good key is D corresponds to S, E corresponds to P, and so on. So the way we write this determines the way we write this. So therefore we can use this as a way to figure out which parts are congruent. So to find the value of X, we see we have this has X in it and this has X in it. But this one up top for QR only has X in it, whereas angle Q we have Y and X. So we want to just use the one that just has X in it. If we look at QR, QR corresponds to FG in the other figure. So if you notice, it's like this one's been twisted around. So FG is here, QR is here. We can say 2x minus 4 equals 12. Adding 4 to both sides. 2x is equal to 16. And dividing both sides by 2, x equals 8. Then we're going to take that 8 and we're going to plug it in here. And if you look carefully, let me erase this real quick. Angle Q corresponds to angle F here, so we can say Q and F are equal to each other. So that means that 6y plus x is equal to 68. And since x is equal to 8, we can write 6y plus 8 is equal to 68. Subtracting 8 from both sides, we get 6y is equal to 60. And dividing both sides by 6, we get y is equal to 10. Okay? So again, the first thing we do is we set FG and QR equal to each other. We end up with 12 equals 2x minus 4, or 16 equals 2x, or x equals 8. Then we take F and Q equal to each other, and we're going to plug in 8 for x here. So we get that. We subtract 8 from both sides and divide both sides by 6. We get y equals 10. For this next one, we want to know will the sections of the wall be the same size and shape if we divide it the way it's shown? Remember that congruence means that something has the same size and the same shape. So we want to make sure all the parts are congruent. Well, let's see. We've got angle A should correspond to angle C, because it looks like this one's in between 1 and 3. That's also between 1 and 3. So we can say angle A is congruent to angle C. We can say angle D corresponds to angle B, and those are both congruent. Angle 3 here, since it looks like these two lines are parallel, because we've got that this line AB and DC are both perpendicular to the same line, so therefore they should be parallel to each other, and so angle 2 and angle 3 should be congruent. And using the same strategy, we can say that angle 1 and angle 4 are congruent. And remember, the reason why these are congruent, we could just say for these ones, we can say all right angles are congruent. And for these ones right here, we can say alternate interior angles theorem. And then the other ones are just basically because it's given. So we can say AJ, because it has the same markings as KC. Those are congruent. AD is congruent to BC. DK is congruent to JB. And these are all because it's given. And finally, we have JK congruent to JK. And the reason for this would be the reflexive property. Okay? And I'm going to show you what they wrote, but it's just basically saying the same thing. We know that AC and A and C are congruent, D and B are congruent because all right angles are congruent. Again, lines perpendicular to a transversal show me that the lines are parallel. Since the lines are parallel, we know 1 and 4 are congruent, 2 and 3 are congruent because of alternate interior angles. And so all corresponding angles are congruent. We know AJ and CK, KD and JB, DA and BC are congruent because it's given. Reflexive property tells us this, so all the parts are congruent. So we can state that. This is similar to the example before this, not the last example, but the one right before this. If we look carefully, we want to see what H corresponds to. H corresponds to F, so those two are congruent. We would state, the first thing they want us to do is state all the parts that are equal. So let me erase this real quick. We know angle A is equal to C. And I kind of cheat a little bit. I just use what's here. A and C are congruent. B and D are congruent. G and E are congruent. And H and F are congruent. And again, you can look at it and go A and C, B and D, G and E, H and F. And then also we can state that AB, because it corresponds to CD, those are congruent. AB and CD. BG and DE. GH and EF. And finally, AH and CF. And again, going back to what I was going to do originally, we know that H and F are congruent, so therefore we can write that 4x plus 5 equals 105. We subtract 5 from both sides. 4x equals 100. Dividing both sides by 4, x equals 25. Okay? So all the parts that are congruent, those are all the corresponding sides, all the corresponding angles, and then we want to find the value of x, and I want to know the measure of angle h. I didn't do that, but hopefully you can see that since h and f are equal to each other, you don't even really need to plug it in, but the answer should be 105. So this gives us our answer. For part B, we know h and f are congruent, so angle h is 105. And finally, we want to show that these two triangles are congruent. In order to do that, we need to state all the parts that are congruent. So we look at this and we say PT is congruent to TR, or RT I should say. And again, I kind of just cheat here because I can see that those match up. They have the same markings. Try to do both. Look at this and then look at it here. Make sure it matches. So then we have TS congruent to TQ. And again, here's TS, here's TQ. And PS is congruent to RQ. And PS and RQ. That's because for all of these, it's marked on the figure, so it's given. For, if we look, these two lines are parallel right here, so we can state that angle P and angle R are congruent. And we're going to need this later, so remember this. Also, we can state that angle S and angle Q are congruent. And the reason for this, again, if those two lines are parallel, it's kind of hard to see, but I'm just going to draw it here real quick. If this line is parallel to this line, and we know that those angles are congruent, call this my P and call this my R. Can we see how it relates to the picture up here? And the same thing's going on with S and Q. These are alternate interior angles, so we would say alternate interior angles theorem. And then finally, we know that this angle right here and this angle right here are equal. Do not say that angle T is congruent to angle T, because we don't know what we're talking about when we say angle T. We need to name it very specifically. So we would say angle PTS is congruent to angle QTR. And the reason for this would be that vertical angles are congruent. And that would be it, because we would have all three sets of angles, all three sets of sides are congruent. Therefore, the two triangles are congruent. In the future, this is actually a proof what we've done here. In the future, we'll only need to show certain things, and we'll learn that as we go through the chapter. So again, yeah, all the corresponding parts are congruent, so the two triangles are congruent. And that's it. Thanks.